All right, so this is just going to be a refresher on factoring quadratics. I'm recording this with the understanding or the expectation that you've done it before and you just need a refresher. We're going to look at two types of quadratics. We're going to look at quadratics that are already in standard form, meaning the leading term is the highest exponent, it's the squared exponent, and the exponents decrease in order. So we have x squared, x to the first, and then our constant term. We're going to look at quadratics where the leading coefficient is 1, and then where the leading coefficient is greater than 1. So first, let's look at the one where the leading coefficient is 1. So we're going to think to ourselves, we want to find two numbers that multiply to give us a times c, that add together to give us b. So if this is our A, this is our B, this is our C, we're looking for two numbers that multiply to give us negative 15, that add together to give us negative 2, and those two numbers would be negative 5 and positive 3. So then I'm going to fill in my 2 by 2 area model by expanding this negative 2x and rewriting it as negative 5x plus 3x. Those are the two numbers that I got here when I call this my magic pair when I tried to find the two numbers that multiplied to give us a times c that combined to give us b. So then we're going to just rewrite that negative 2x as negative 5x plus 3x, and then fill in here. So our a term goes here, our c term goes here, and our b term is split up between those two on the diagonal. And it doesn't matter whether the negative 5x goes here and the 3x goes here, or you can reverse it. That doesn't matter. Then we're going to look to see what those two terms in that first row have in common. They share an x. These two terms share a positive 3. And then these two terms share an x. And these two share a negative 5. So then this factors to be x plus 3 times x minus 5. And if you notice, in this case, that's what we got here. We got x minus 5, x plus 3. And so when your leading coefficient is 1, like it was here, you can just go straight from these two numbers here to your factors, x plus 3, x minus 5. It's a little different. The process is the same, but it's not, you can't take that shortcut when your leading coefficient is greater than 1. So we're going to identify our A, B, and C just the same way, except this time we are, well, it's the same. But we're looking for two numbers that multiply to give us negative 10, that add together to give us negative 3. And so the two numbers that multiply to give us negative 10 that add together to give us negative 3 are going to be negative 5 and positive 2. So then we're going to bust up this negative 3x and rewrite it as negative 5x plus 2x and split it between these two boxes on the diagonal in our area model multiplying template. And then we look to see, just as we did on the left side, we look to see what the first two terms have in common. They share an x. Second two terms don't seem to have anything in common, but every number has a 1 in common. So that's going to be x plus 1. Then we look at the first column, and these two terms share a 2x. And the second column, and these two terms share a negative 5. So then when we factor this quadratic, it factors to be x plus 1 times 2x minus 5. And that is just your basic overview of factoring quadratics when the quadratic is already in standard form and your leading coefficients are either 1 or your leading coefficient is greater than 1. I hope you found this helpful.